Hello everybody, Toby Delbruck again. In this particular video tutorial for jAER, I'm going to show you how to control the biases on a Davis240C. Again, I'm going to run from the development branch of jAER and NetBeans. And I have two cameras plugged in, just as before in the previous tutorial for the DVS128. And this time I'm going to show you the Davis240C, which is a dynamic and active pixel vision sensor. So since I have two cameras plugged in and I want to use the Davis240C, I'll switch to that Davis240C. And by the way, one thing you can do is open another viewer. Actually, we get an uncaught exception here. So this is very good because I'm now going to copy this to the clipboard, open the jAER user forum, and show an example of how you can report this bug to the user forum. I'm going to make a new topic here, uncaught exception. So let's just paste that exception that we just got here. And that will basically send a mail to me and to other people at Innovation. And we'll try to fix that bug. So the best way to get these bugs fixed is actually to report them. It's okay. Now if I close this uncaught exception window, it will go and stop jAER. And now let's run it again. And it may actually now start up with two AE viewer windows, but usually it starts up with the most recent configuration. Okay, so let's not worry about two viewers for now. We're now selected the Davis240C, and now we've got to select the Davis240C hardware interface, which is Davis FX2 here. If we do that, it tells me that device firmware revision is too old. So I have version 3, but at least version 4. So this particular Davis240C camera needs its firmware updated. So I'm going to go and do that. You can go look at this web link here, or you can go to help and go to flashy reflashing utility help, and it should come to the user guide for reflashing devices. I'll pause the video while I go and reflash the firmware on this camera to bring it up to date. Okay, I'm back. I managed to reflash the firmware on this Davis240C. So now that I see that it has appeared here as Davis240 serial number 96. When I reflash the firmware, I managed to reflash it as a DVS128. So there was quite a song and dance erasing that firmware and getting the correct firmware onto the camera. So here I am. You see the DVS output with Hakeem Olajuwon in the background, and the usual scene of our office here. And now we're just showing DVS output. If you go to the hardware configuration panel, you're going to see a much more complex object than you did for DVS128. A lot of the things that are useful day to day can be controlled for the Davis from this Davis menu that gets installed here. For example, I can do Shift F or toggle frames to toggle the frames on and off. I can do Shift E to toggle the events on and off. So now we just have frames. I'll turn the events back on. I'll change the color mode on the events using C. So now I have a superimposed view of the events and the frames. And now I can do other stuff. For example, I can turn on the inertial measurement unit, the IMU. Every time I do Shift I for IMU, now it's disabled. Now Shift I, the IMU is enabled. Now you see, I'll turn off the frame so you can see it a bit more clearly. You can see the IMU output in the middle of the display here. The purple things are the rate gyro, which tells you how the camera is panning, tilting, and rolling. And you see this is the roll and pan and tilt in degrees per second. The green is the accelerometer. Right now, since the camera is oriented vertically, it's telling me that I'm accelerating -1 g. So it's telling me that gravity is down. If I rotate the camera on its side, you see how gravity points to the right and to the left. And now in the Z direction, the accelerometer is represented by this green circle. So let's turn off the accelerometer for the moment. By the way, the accelerometer also has a temperature measurement, so it tells you the camera is at 28 degrees centigrade, or at least the IMU is at 28 C. So I'll turn off the accelerometer, I'll turn on the frames again, And another thing you can do is turn on the histogram for the frames. You see right now that if I make the image really bright, for example, look at the lights on the ceiling, you get a distribution between bright and dark pixel values. Another thing you can do from the Davis menu is toggle this auto exposure. This is a kind of auto exposure algorithm that sets the APS exposure time. For now example, if I stop down the lens, I think it's here. If I stop down the lens, I'll just put some sunglasses in front, perhaps that's easier. If I suddenly make the image darker, and I guess auto exposure is not enabled, so the frame exposure time, which is shown here at the top, doesn't do anything. But if I hit Shift A to turn on auto exposure, it gradually increases the exposure time. Now it'll be overexposed, and the auto exposure control loop will gradually decrease the exposure time. Another thing you can do to control the display of the APS output, I'll turn off the events for now, is to control the, I believe it's auto contrast. So now auto contrast is false, so the contrast of the display is just set manually. If I do Shift C, I think, auto contrast is true. It tries to somehow fit the captured image gray levels into the display range. If you turn auto exposure off, now you'll see that there is shift up and shift down, increase and decrease the APS exposure. So if I do shift down, I'll decrease the exposure time. Of course, the pixel gets dark. Shift up, I can increase it until everything is completely overexposed. And now you get actually some fixed pattern noise from the readout circuits. Okay, so that helps you set the APS exposure, either manually or automatically. You can also increase and decrease the APS frame rate using this menu. So if I do Shift left, you see that the frame rate here, which is displayed here, decreases to 1 Hertz. If I do Shift right, the frame rate increases up to, I think, its maximum value at this exposure level. Or if I decrease the exposure time a lot, I can get up to about 25 Hertz frame rate. But of course, the frame rate is dependent on the exposure duration as well. So let's set it back to some moderate rate. In fact, just leave it there for now. Yeah, so that's it for the Davis menu. Now let's focus on this control panel, which you get to by this hardware configuration button. You have a rather complex control panel that does many of the same things. For example, if I can stop capturing, right now I'm not capturing events or displaying events. If I display events but not capture them, nothing comes out. If I also display them, you see now the events are being displayed. I can capture frames but not display them. Or I can not capture frames and display frames, and then the frame will just be fixed to the last captured frame. I can also take a snapshot, which is 1 frame at a time. So every time I move the camera, I get a new frame, and so on. It's kind of self-explanatory. You can see the frame delay here, the exposure delay. That's the time between frames. You can also have other settings to capture frames every certain number of kilo events. So if I do this, increase this to set it up to, say, 100K events, which I can do with the mouse wheel. Now it'll only capture an APS frame every few hundred kilo events, every 100 kilo events. So now the frame rate will get very low. You can tell that because this little white bar, which advances every time a new frame is captured, doesn't advance. As soon as I move my hand, it starts to capture frames. If you want to turn this off, because this is a result of some confusion, just set this back to 0 and toggle capture frames, and it should go back to just standard conventional constant frame rate capture. You can also control auto exposure here. You can switch between global shutter mode and rolling shutter mode. You see rolling shutter mode seems a bit less noisy, but it does have motion artifacts. If I turn the events false and now move the camera around, you can see how the camera image becomes distorted a bit because of the rolling shutter readout. If I go back to global shutter mode here, you see that you don't get the same kind of image warpings that you get with rolling shutter mode. Again, you can toggle the histogram here on and off. if you're interested in the pixel values. For DVS, you can capture events, display events. Let's turn off the frames for now. You can also set the contrast here using the slider, these buttons here to increase or decrease the contrast of the rendered events. It's probably easier to do that with the mouse wheel in the main window. You can also set whether you want to show the events as grayscale or red and green here. This is equivalent to using the C button to control the contrast display in the main window. Just as for the DVS128, you can adjust the individual pixel bandwidth, the threshold, the refractory period, and the balance between on and off events using these controls. And so see the previous video to see how to use this user-friendly control panel. Now I'm going to march you through some of the rest of this complex hierarchy of hardware controls. So if you go to the IMU config, you can now set the full scale range of the gyro and the accelerometer. You can also set the sample rate divider for the IMU, and you can set the digital low pass filter mode. If you're interested in maximum update rate, you toggle the IMU on, and then you can play with these settings here a bit to see how they affect your values. Now, a very useful control when you're synchronizing the camera to some external device is this external input config. On the back of the camera, there are two audio jacks, what look like audio jacks. There's an in one and an out one, which are printed in reverse because of the problem in the PCB design. But if you plug something into the in port using the stereo jack, you can then set special events to be written into the file depending on various conditions like rising edge, falling edge, pulse detection, pulse polarity, and you can control various other things here which you can look at. To some extent there's help for these. If you have any questions about these, ask questions on the user forum. The next tab is chip config. This is really designed for developers, for us developers internally. This thing wouldn't be used by any normal user, but it configures digital multiplexers on the chip to multiplex out particular internal digital signals that we use while we're developing the camera, including an on-chip bias generator, calibration, integrated and fired neuron, a setting for this, various settings to bring out experimental features that are not normally used. Another important control for users is probably this IPS auto exposure control. APS auto exposure, which I'll play with here a little bit by turning on the frames again, is set by this control panel which determines how the exposure of the frame is determined. You can enable center weighted, you can print debugging output to see what's going on, you can control the rate at which things the auto exposure is changed, also the high and low boundary for when it considers the picture is overexposed or underexposed. You can enable proportional or just bang bang control, and you can set the fraction of pixels which are considered to be over or underexposed, in which the control policy actually changes the exposure. The video control panel here doesn't affect anything about the hardware. It just affects how these values are displayed on the screen. It allows you to set things like the contrast here, which is disabled at the moment because I think auto contrast is enabled. So if I disable auto contrast with Shift C, now I can manually control the displayed contrast. Yeah, I guess that's it for this one. The bias current config is a complex control panel which displays for each of the circuits on the chip the bias generator, determines the particular type of bias it puts out, N or P type transistor, whether it's enabled, whether it's configured for normal or cascade configuration, or whether it's using a shifted source biasing scheme. It also configures the coarse and the fine values of the current dividers that finally determine the final bias current value, which is displayed on the right here. By the way, these actual displayed current values are fairly close to the physical values on the chip. For example, the diff-BN, which is the differencing amp that detects the changes in log intensity or brightness, currently has a bias of about 7.4 nanoamps. Another useful thing is this multiplexer configuration. Multiplexer determines how the DVS and APS and IMU samples are sent to the computer over USB. The question is, what happens when the bus becomes full? In other words, when the host has not processed all the USB buffers and there's no room to put new data. This multiplexer configuration determines what kind of data is dropped. So MUX drop DVS on transfer stall, drops DVS when the USB FIFO is full, but then it ensures that full frames are still transferred to the computer. You can drop APS on a transfer stall, you can drop IMU on a transfer stall. All these things may be necessary under certain conditions of high bandwidth. In addition, there's a USB early packet delay. Early packet delay means how willing is the camera to commit USB packets to be sent to the computer even when the FIFOs are not full. And if you're in a low latency situation, you want to set this number low so that packets are sent to the computer even when the FIFO is not full. So that may be in a situation where you're trying to close real-time control loops. If you have questions about these, ask on the user forum. The DVS config here enables various things having to do with the state machine that controls the readout of the DVS. Some of these things affect the output from the DVS. On the Davis240C, this option, DVS filter background activity, actually doesn't do anything because there's no room on the CPLD to do it, to put this machine. So if you now turn off the frames and look at the background activity and disable and enable this won't have any effect. Of course, you can achieve the equivalent effect if you just simply use the software background activity filter here, which gets rid of this noise background. The final one is APS config, which enables the active pixel sensor output. Here, if I enable it, I don't see anything because I'm not actually displaying the frames. But if I now go in and display the frames and enable and disable this, you'll see that if I disable it, the frame is frozen. See how the frame is not changing in the background? Okay, now it's changing in the background. This is all specialized stuff that affects the readout of the image sensor frames. And to understand this, you need to understand the actual circuits on the chip. So most users will just use this user-friendly control panel. If you're a specialized user and you need to control specialized hardware functions like the inertial measurement unit, then you need to know the hardware a bit better. By the way, if you have never run a Davis240C before, you need to load a set of default settings. That includes all these bias current settings and all the settings of the bits. The way you achieve that is by going to the File menu here of this hardware configuration panel and going to Load Settings and then navigating to the proper folder in jAER of Bias Gen Settings and finding the folder for your camera, in this case a Davis240C, so we have Davis240BC, and then you can pick one of these default configurations. That will reset all the settings to some default values. For example, if I pick this one here and say Open, you'll now see that a bunch of these bias currents have changed their values. And now the camera is set up in some default mode. So that concludes this brief tutorial on using hardware controls for the Davis240C and other Davis cameras. Thanks for your attention.